Hey guys, what's happening? Hey Murphy, what's up, bud? Good to see you here, bud. Good to see you here. Got the biscuit? First one in here, huh? Well, you got it then, man. Hey, what's up, Anna? All right, guys. Yeah, we've got a geomagnetic storm. That's exactly what's happening. I'm gonna give everybody a couple seconds to get in here, because again, this is some funky time to be uploading trying to do a live stream. It just never works out very well for people to come in here. Only people that see this are people that have the notifications turned on. Um, so if you could, please do that for me. I would really appreciate that. By the way, I don't normally ask for that stuff, you know. But yeah, on a video like this or a stream like this, at this time of the day, yeah. Anyway, guys, yeah, we're under a G2 storm right now. Um, and it just was expected. Okay, as a matter of fact, we got this here just now updated. All right, so we this geomagnetic storm is actually already overachieving. And what I mean by that is, if you look at their forecast here, they weren't expecting us to get into G1 until right around 6 UTC, and we got into G1 right about the turn of the day. So, and then it went up from there, right? They weren't expecting these G2 conditions until noon UTC, which is roughly about, what would that be? I'm trying to think here. We're 4 hours different. Anyway, it'd be 8, I believe, on the East Coast. So, as we are looking at this, we will, again, take a look at it. So you got, this is X-ray production. This has nothing to do with this geomagnetic storm. What's causing this geomagnetic storm? Well, let's go take a look at that, and we will. I'm just going to use SDO today, guys. I usually take you guys over to ISFA because the definition seems to be a little bit better. But for what we're doing here, I just want you guys to see a coronal hole. That's pretty much what I'm going to show you right here. So yeah, and we'll take a look at it in a few different angstroms. The best one, in my opinion, for looking at coronal holes is 211. That's the purple one, and again, they could assign that any color they want. They're going off of that number, 211. That's extreme ultraviolet, but that 211 is part of the light spectrum. It's an angstrom of light. Okay, so it sees specific things that our eyes can't see, and that's why they do that, so we can see different gases, different features on the sun, and it's made a big, huge difference on how we're able to, forecast these kinds of events. So, with that said, you got the 211 there, and so we'll submit that. And I would encourage everybody to go check, do the SDO thing. Go over there and start messing with this. I'll put the link in the live chat for you guys, and we'll see how we get going with that. So there is the link to SDO if you guys want to come over here and mess around. You can't hurt nothing, okay? You just really can't. But I want to point out how large this coronal hole is. It's most definitely a sizable coronal hole, and it's deep. A coronal hole is exactly what I just said. It's a hole in the corona. It's not a hole in the sun. It's a hole in the corona of the sun. That's kind of a misconception. A lot of people come over here and they'll look at this and they think that what they're looking at there in the black is like a hole in the sun. It's not. That's the surface. Why is it black? Because it's colder. I know it's hard to believe that. You would typically think that the surface should be hotter, right? Because that's what you would think, that's where the energy's coming from for the corona. Well, they sent the Parker SP probe out there to kiss the sun, that satellite, and they've come back with some really good data and some new theories and things. I think they called them kickbacks or something like that. But the UV gets into the atmosphere of the sun coming off of the surface, and it does like a kickback thing, like an up and down. It basically is kind of zigzagging, and when it does that, I guess it produces more heat. So You know, and that's a very basic what I just said there. There's multiple articles written on this thing now, and you know, if you guys are going to read some of those articles, I would definitely suggest carrying a dictionary with you over there because some of the words that they use are fairly big. They're, you know, there are words that we don't typically use in our, you know, our normal language, and especially my hillbilly language. And if you don't think I have hillbilly language, then just ask a few a few of the people that have left comments. Sorry about that, guys. I'm still sick. I tried to cover the mic there. I hope I didn't burn somebody's ears out. Yeah. Anyway, so that's the 211. Now what we'll look at next, I'll go ahead and bring up the 193 is fairly good. You know, it shows it pretty well also. So we'll take a look at that real quick. Okay. See how it looks a little bit smaller than what the 211 showed? It's because it's looking at a different gas. Now this will show different features better than the 211. That's why we look at different ones. You can actually see the lines of magnetic connectivity here. You know, those big arcs we see and the filaments that are kind of laying across the sun. So we'll look at the 304 now to give you a really good idea of how different these things are. This is, I believe this is ionized helium is the gas that this is looking for. But do you see a coronal hole in this one? No, you don't. And that's what I'm trying to say. Doesn't mean it ain't there, because there's definitely a hole in the corona. The sun is what's letting all these highly charged particles flow at us. But that's that eruption I showed you guys, that filament release. Watch what this thing does. And I showed it to you guys yesterday also. But you'll see this energy, see it? Just like that. Notice that it started over here, okay? There was some solar rain over here, and it destabilized things. And it actually went all the way across the surface of the sun and almost did like a reverse. And it's not really reverse. It's thought that what it is that's charged particles on a magnetic connection line, right? So it's going back to ground, and I ain't going to say ground because that's an earthly term. We won't go into that, but it did, and you look almost. Rip actually said it looked like a rip curl readiness. He said, "Hey, that looks like a lightning strike," and it kind of does. And somebody else said that too. I forget who else said it in the chat, but where it ended up was right there where that corona hole is. It's interesting because it went right to the surface. Now you still got solar rain over here. And again, solar rain is the same thing I just said. It's charged particles on a magnetic connection line. It's plasma. Okay? You see how this stuff just kind of... This is cool stuff to look at. Now, again, we're in a geomagnetic storm, so we're going to... That corona hole is what's giving us this storm. Okay? And oftentimes, like I've been saying a lot lately, these things will outperform a coronal mass ejection. A CME. Okay? So, that's, yeah, we have to realize that when we're looking at these things. We have to understand that just because a CME looks impressive, way more than what we would see with a coronal hole, as far as like the LASCO imaging, the coronagraphs, those look very, very impressive, right? But this, you can't really see a coronal hole stream on a coronagraph. They kind of show up like jets. They look like a little focus like flares. And it's not a solar flare, so that's why I didn't want to use that word. But anyway, so if you look here, this is the discovered data. Remember, on the BZ, that's the orientation of our magnetic field. And then when it gets into a negative field, negative tilt, and a -6 or bigger tilt is what we look for. Anytime it's -6 or bigger, tilted towards the south, you're going to see this thing turn purple. And that's when the stuff is actually coming into our system. It allows it to come into our system a lot easier. Okay, so that's why that's important to know. The phi angle did flip right here. That's the polarity of the solar wind. I'm not going to go too much into detail on that right now. But that's what that is. When somebody says phi angle, That's the actual polarity of the solar wind. Solar wind gets here from a magnetic connection line from us to the sun. The sun is literally connected to everything in the solar system, including the satellites. Okay? So, yeah. But you go down here to density, and you kind of see density here. It's hanging around 11 or 12, which isn't all that high. 4 is what we would kind of consider ambient normal, I guess, if you want to use those kinds of words. But the speed is what we're looking at here. 300 to 500 kilometers per second, right? That's what we look at for, again, what we would consider kind of normal. That's the purple line here, and watch what it gets up to. Right now it's hanging close to 700. And to put that into perspective for people that kind of live here in the States, for every, I think it's for every 400 kilometers per second, it's roughly 1,000,000 miles per hour. So put that in your mind and try to wrap your brain around that. It's moving fast. That's all I can say. You know, when we look at these things. So what did I do there? Okay. So again, there's the discovered data. Obviously, the temperature typically goes up also. That's just because of what's going on. There's more friction. There's more drag when the density and the speed's more, right? So that causes more heat. And that's what you see there. Now, I'll tell you what we'll do. We'll go to the geomagnetic, or the magnetosphere tool. Now, guys, I haven't even scrolled down yet, so I don't need anybody freaking out, okay? Because I know some people are going to think that this is crazy looking, right? And it is compared to what we typically see during normal, calm conditions, okay? Obviously, anybody that's ever watched my channel knows that this is definitely an uptick, right? And this is kind of what we would expect from a big coronal hole, right? So if I push play here, and this is just the speed, velocity, we'll watch this for a second. And what you're going to notice, now remember up here on the key here, if it's above that number there, you're really not going to get a difference in color here on this model, because it stops at that color. So things could be moving actually a little bit faster than what they kind of show. Once it gets to that peak, the model really doesn't show anything past that peak. It just says, hey, this is fast. Kind of, sort of. But yeah. Now the density, again, density is going to move around, and typically it's going to drop because things are moving faster and it's flushing it out behind us, those particles. Sorry, guys. Wow. But watch this. I mean, you can see it moving around. Our bow shock, yes, I went over this yesterday, is still there. It's just the density on one side of the bow shock to the other side is the same. The bow shock is the point where solar wind meets our magnetic field, or any magnetic field for that matter, you know. That's pretty cool, Evelyn. Guys, I am so sorry. I'm sitting here coughing bad. I'm still fighting, you know, pneumonia and bronchitis. So that's kind of what it is. Hey, Daniel, what's up, bud? Good to see you, man. Now, guys, when you look at this, obviously this is such a bigger uptick than what we usually see. And again, we're looking at geomagnetic storm level G2. Okay, we're not looking at something that just barely moved over the threshold, right, into storm level. This is one of those things that we're in a geomagnetic storm, and it is significant, right? We're not talking grid down, or not even close, okay? But, you know, this kid, what you're going to see, I haven't looked at the Aurora one yet, but when I show you guys the Aurora here in a minute, I'm going to look at it for the first time with you guys. You're definitely going to see some Aurora. I mean, yeah. I am so sorry, guys. Man. But that is quite a bit. Okay. So let's go ahead and take a look at the Aurora. Yeah. Okay. That's exactly what I would have expected to see. This is northern hemisphere, southern hemisphere, right? You've seen the uptick kind of at the turn of the day anyway, so things are kind of, expanded out and are reaching down. Look at that. Look how far down south that's reaching. This is the North Pole. So when you start seeing it reach down like that, you're getting hit pretty good. And it's just going to kind of, we'll see how close it comes to our northern border for those of us that live in the States. See, look at that. Look, check it out. I bet you Maine's seen some Aurora there. Betcha. And down through here also, around our northern border there. So we'll play that a little bit more. Oh, look at that. Check that out. Oh, yeah. This definitely, that didn't just stop at the border. That sucker come on down. So, yeah, there's going to be some great Aurora photography out of this. I guarantee it. And again, it did arrive a little early. So what that means is it was moving faster than what they thought. And typically will add a little bit of intensity to the storm. Make it a little bit more stronger. Density can also do that, but yeah, Washington State for sure, Murph Dog. You definitely will see that. It almost covered the whole state here. That's not even the end of the run there. Let's run the rest of it. Okay. So it kind of shrunk back down. You'll see these fluctuations also. So, but yeah, that's pretty intense stuff. Now, I always like to look for my brothers and sisters down under here. I like to see if it reaches down into Australia or New Zealand and stuff, and it looks like it might be. So that's pretty cool for those guys too. So, yeah, that's Aurora. Now, I will go ahead and show you guys, let's look at the geoelectric field model. I haven't looked at this yet, so I bet you this thing is probably pretty intense too. This is space weather's effect on our electrical grid. This isn't geomagnetism, this is geoelectric. And they use this to help try to forecast earthquakes. And yeah, you can definitely see, yeah. Start seeing those reds, all these colors here. Look at that. I mean, the red stretched all the way down to there. And again, with Aurora pushing down as far, I wouldn't expect to see this model look any different than what it is. It's showing exactly what's happening here. And, looks like they got this one right, guys. Okay? Yeah, they did. And a lot of the reason is because we didn't have CMEs firing off with the coronal hole at the same time. At least not a whole lot of them, like we did a couple weeks back where we were seeing so many M flares. It was hard to even pick up a coronal hole stream. You would see it bump up a little bit like this. And that's how we were kind of watching when those things would hit. But yeah. Hey, Hilly, what's up, bud? So, we're going to be in G2 here. They're saying we're going to bump back out of it, which probably will happen. It could or couldn't, And then they're saying G1 again does that say G1 or G1? Yeah. With us staying in geomagnetic G2 conditions here for longer than what they expected us to be there, there's an outside chance that these things could end up being a little bit more intense. And again, like I said, guys, what's the biggest thing here we're going to see? Aurora, maybe some uptick in some earthquakes, maybe some first responders. They use, radio systems, shortwave radio systems, and that affects their communications. Okay, so they watch this stuff diligently because it will. They'll get radio blackouts from flares, geomagnetism. You'll see it affect all that stuff too, including GPS at some level. Now remember, they were supposed to be firing that rocket off yesterday, and they scrubbed it again because they couldn't seal off a fuel leak. But if they had fired that thing off, and I know that they know these things are coming, right? I mean, I'm not going to sit here and pretend that ain't what's happening. But if that rocket was to get out there and this storm hits, you would think it might affect it because you can get surface charging during these things. And that's going to, mainly what that's going to affect is our satellites and obviously a rocket if it's out there. Okay. So that's my whole point there. And surface charging can be pretty bad sometimes. It can really get into the controls of the spacecraft. They oftentimes have to reorient and make adjustments to the navigation on the satellites. They have to steer them back into place because things are getting moved around and everything else. So, I mean, that does happen. So if we got this brand new rocket that's shooting out there, it's supposed to go out and do a figure eight around the moon and come back. And it's out there. Once it gets out there like that, guys, it doesn't have the protection of our magnetic field. So it's going to catch everything that's just out there. You know, and I know that the space station's been up there and they get hit quite often, but the space station is actually lower than what people think it is. I'm not sure exactly the height, but yeah. Now, again, I'm not going to sit here and talk about any of the stuff like, did we really go to the moon and stuff? That's not my point here, guys. And you're welcome to have that opinion. I mean, I've seen a lot of information on both sides of it, okay? And, you know, I'm not here to tell people how to think. I'm just reporting on what I see, and what we get, guys, we get these models, and, you know, there's not a whole lot more, you know what I mean? You know, unless you have quite a bit of money, you can go out and get your own telescopes and stuff, but that's expensive. I think Hilly's got a telescope. I'm not sure how big it is. Bruce Swartz has a 14-inch telescope. He gets some really good captures on. That's Bruce Sees All. You guys might go check him out. He's got some pretty interesting data. But yeah. So let's take a look at seeds real quick, and just so you guys can kind of see what's been happening here. This is LASCO C2, right? This is the Soho Observatory. What the observatory is the satellite. It's about a million miles closer to the sun than what we are, and it's looking from our perspective. And that's back on the 2nd when we had that eruption. Okay, the models do show this thing clipping us, but I'm kind of half timid to even come out and say, hey, we're going to get a geomagnetic storm from this thing, because there's so many variables that could happen. So we're going to kind of wait on deciding on if that thing's going to hit us. But what I will say is this, that the models do show, yeah, right here. Okay, this is the NASA Enlil spiral model. That's Earth, that's the sun. And that's that CME right there. You can see how it kind of clips us. Now you got 3 different perspectives here we can look at, and it does look like it's clipping us on all 3. But it's so close to the edge, any kind of miscalculation it could either bring a more powerful direct hit, or it can miss us altogether. So, oh, you're talking to Ruth? I'm sorry, Becca. I thought you were. That's why I stopped there. I thought you had a question for me. But yeah, cool. So we'll go to the next day here. This is the 3rd. And again, guys, not much going on there. And this is today. Now, I know what you guys are looking at there. You guys see this kind of bouncing around? You guys want to know why that's bouncing around, in my opinion? This thing's experiencing this solar wind that's hitting us. Okay? That's why you see a little bit of vibration here. This is a black occulter disk that is physically on the camera. So it would make sense if this thing is right out in front of us, always looking at the sun, that it's going to get hit with the same things that we do, but it's going to affect this more because it doesn't have the protection of our magnetic field. So when you see that kind of vibrating like that a little bit, it's not like excessive. I've seen it way worse, but it is doing that. So I'm trying to see if I can see it on the red over here, and you think you can a little, just not a whole lot. But yeah, so let's go look at our our partially side view. And I've been explaining this too. See, this is the Earth, this is stereo A, and I'm going to take you, show you the view from that satellite. This satellite used to be over here. So we had like a pretty good backside view of the sun. Well, it migrates back, and this was on purpose, okay? These things have outlived their lifespan. All right, this from now on, it's just a bonus what we get. right? But yeah, so there you go. So this is the perspective. And if we come down here and look at the perspective, this is what we're going to see. Okay, that was yesterday. And then we'll look at today. And I know you're seeing those, but guys, this thing is probably glitching a little bit because, like I showed you guys, that CME that blew off the sun, I'm not saying it's hitting it right now, but it is directly headed towards stereo A. Okay? So whenever it like sees a massive amount of light, that coronagraph tries to correct that and give us that image at all. So, but yeah, so that's what we're gonna do. Guys, you guys go over and check out the lifeboat. I know I talk about it about every stream just for a few seconds. I won't be there tonight, but Tommy will. Okay, guys, please go support him. I got something I have to do tonight, so I can't be there for the live stream. Please go show him some support and love. I know he would, really, really appreciate it. It takes two of us to run the show most of the time because we're doing call-ins and stuff. But he's going to be there by himself tonight, so we'll give him some love, Stop in and say, hey, go check us all out, guys. I mean, honestly, check us out over on the lifeboat, and you won't be sorry, I promise. I mean, honestly, guys, I really don't think that anybody's would be sorry going over and checking it out. If you know anybody that's in addiction, or if you just want to learn yourself, if you yourself are in addiction, we can help. Alcoholism, all that kind of stuff. We'll get you to the people you need to talk to. We talk to you. It's a family over there. It truly is. And the family gets bigger every day. And I'm very proud of what we're doing over there because I'm actually giving back. And I see it right away. And because, I fought the opiate addiction, and I did a lot of bad stuff when I did that. And, it's kind of helping me wrap my brain around, hey, I'm okay. And I'm trying to, do better, right? And it's 11 years, 11 years ago is when I actually got sober. So I had a pill addiction, and that's what happened there. But I want to help people that are going through what I went through. All right? And that's why I say that. So what are we going to do here? I'm going to go ahead and drop the link here. And what you're seeing here, this is the live stream we did tonight. Heck, anyway, I'll just click on it, I guess. Sorry. So, yeah. I wasn't expecting this geomagnetic storm to be here yet, or I'd have been a little bit more prepared there. I apologize for that. So I'm going to drop the link in here, guys. Here it is. And check out the title there. If at first you don't succeed, try. It's a call-in show, right? Actually, it should have said quit. Because that's what we say over there, It's about the only thing you really want to be screaming, hey, I'm quitting. You're going to quit the drugs, right? I mean, that's kind of what we look at there. But what I will say here, I do want to go to his channel. Hold on a minute here. It's my channel too. But he started it. Oh, goodness. I don't know why it ain't giving me the first one there. That's kind of crazy. Anyway, the video we did today, go over and check it out. It's titled, Where Did All the Heroin Go? Think about that for a second, guys. Go watch it if you want to know where it all went. Because, yeah, you have a hard time. Anybody that is in that life right now would be having a hard time finding heroin. So, and believe me, there's a beast that's a lot stronger and a lot more powerful that took its place. So go over and check that out, guys. It was a good show, so please do. But thanks for coming here, guys, and supporting me. I do really appreciate it. Anything else happens, I'll definitely come back on here and let you see and let you know. But we are definitely in a geomagnetic storm as we speak. I'm not sure exactly how long this particular hit is going to last, but we'll see. I appreciate all you guys. Thank you guys for trusting me to go over to these other channels that I, shout out to you. it really means the world to me. It really does. I never thought that I'd be sitting here talking to people that, you know, I have a channel over 50,000 people, and it's so humbling to think about that. So thank you, mods. You guys rock. Always the best. Never have any issues. I know sometimes it gets rough in here, but you know, my mods do a really good job, guys. They let everybody have their opinion as long as it doesn't get personal. And you know, that's kind of what I've asked them to do that, and they do a really good job at it. You come in here and slam me all day and call me stupid, but please don't do that to somebody else. You know, or talk bad about another channel when they're not here. You know, if you're gonna talk bad about somebody, don't you want them here? That's what I'm trying to say. So, you know, that's why I don't allow people to even go snap off of any other channel. That's why. Because it's just simply not fair. They're not here to defend themselves. Also, I believe I'm going to have Tommy over here either on Wednesday or Thursday this coming week. We're going to be talking about some navigation things, and I'll get more into that later on, and we'll talk about that a little, you know, on those days. But yeah, so there you have it. There's Geomagnetic Storm. I'll probably give you another update either later on. Well, might not be tonight. I'm not sure yet. Definitely, it might be in the middle of the night, or it could be tomorrow. But thanks, guys. Please share out this stream. The reason why I'm asking you to do that is because it is a really odd time to be streaming, and there's probably not a whole lot of people seeing it that I posted here. Okay? So please, do that for me. You know, share that out. I really appreciate it. So, God bless. Yahusha saves, and you can drink this Kool-Aid. Hey, Sid, good to see you, bud.